Who hasn't looked up at the night sky at one time or another and wondered, are we alone? Are there other life forms out there? Though the James Webb Space Telescope launched only 2 years ago, NASA already has its eyes on its next flagship space-based telescope, known as the Habitable Worlds Observatory, HWO. While the new instrument is still in the planning stages and may not launch for at least a dozen years, astronomers are already excited about its potential. The new telescope may finally reveal whether life exists on worlds beyond our solar system. Any discovery of life on an exoplanet, a planet orbiting a star other than our Sun, would be a pivotal moment for mankind, because finally, we would know that we are not alone in the universe. The Habitable Worlds Observatory was first proposed as part of the National Academy of Sciences Decadal Survey on Astronomy and Astrophysics 2020, a 10-year roadmap outlining the most important goals for the astronomy community. Unlike Webb, which primarily collects infrared light, HWO would work in visible and ultraviolet light to not duplicate the other telescope's capabilities. But HWO and Webb will have something in common. They will be neighbors, with the new instrument eventually taking up a position at the so-called L2 Lagrange point, a stable location some 930,000 miles behind the Earth as viewed from the Sun. Unlike Webb, however, the Habitable Worlds Observatory will be designed so that it can be robotically serviced in the future, potentially extending the duration of its mission and reducing costs in the long run. The telescope's actual budget will be up to Congress, but the Decadal Survey suggested a figure of about $11 billion. Assuming it gets funded, HWO would launch sometime in the late 2030s or early 2040. The main challenge in studying exoplanets is that light from the host star overwhelms the feeble light reflected from the planet's surface. The standard solution is to employ a device called a coronagraph. Located inside the telescope itself, a coronagraph is designed to block out the light from a star so that the weaker light from any nearby planets can be recorded. Webb has a coronagraph and has imaged several exoplanets already, but it cannot image small, rocky worlds similar to our own. What scientists want to find are Earth-like planets orbiting within the so-called habitable zone of their host star, meaning that the temperature is such that liquid water could exist on the planet's surface. To directly image these tiny worlds, a coronagraph by itself is not enough. That's because the wave nature of light means that some excess light from the host star will always spill out past the coronagraph, degrading the image. To counteract this effect, HWO will require precision optics that can outperform even those of Webb. The new telescope will employ mirrors that can automatically deform very slightly in real time to minimize the effect of the stray light that gets past the coronagraph. That will require controlling the position of the mirror's surface to within tens of picometers. 1 picometer is 1/1,000,000th of a meter, smaller than the diameter of a typical atom. This technology is already being developed on another mission, the Nancy Grace Roman Space Telescope, an infrared telescope designed to study cosmic structure and dark energy, set for launch later this decade. But the Habitable Worlds Observatory won't just record images. One of the new instrument's primary goals will be to use a spectrograph to break up the light from these distant worlds into a spectrum, which can then be analyzed for specific signals associated with certain chemicals in the planet's atmosphere. Some of those chemicals, known as biomarkers, may signal that something is alive on the planet's surface. One obvious contender for a biomarker would be the presence of oxygen, but oxygen by itself does not point automatically to life. You can produce oxygen in an atmosphere in large amounts, even if there's no life present, just through basic chemistry. A good strategy is to focus on specific combinations of gases, like oxygen and methane. Identifying a signal as a sign of life is tricky, though, because both gases can also be accounted for by non-biological processes. Volcanoes and hydrothermal vents can produce methane, for example, and radiation can split water molecules, producing oxygen. However, finding a planet that has both methane and oxygen at the same time would suggest something is happening on the planet's surface that keeps renewing the supply of both gases. On our planet, plants produce oxygen while animals produce methane. Finding this combination of methane and oxygen wouldn't be a slam dunk, but it would certainly raise eyebrows if you have a planet within its habitable zone, and then you see this combination of oxygen and methane. We have no other explanation for this other than life. Water could also be an important clue, but as with oxygen, water on its own would be ambiguous. The combination of water, potentially detectable as water vapor in an exoplanet's atmosphere, and other key gases would present the strongest case for the presence of life. If astronomers find such a signal on even one exoplanet, it would be a game changer. If we just find one other planet with signs of life, that tells you that the universe is teeming with life. That would revolutionize our view of the cosmos. As excited as astronomers are, they're also keenly aware that supposed indications of life beyond Earth have been overhyped in the past, only to leave the public disillusioned. Those who were around in the 1990s may recall the famous Martian meteorite, which supposedly contained fossilized microorganisms.
And in 1984, an American scientist on an annual U.S. government mission to search for meteors on Antarctica picked it up and took it to be studied. Rock number 84001. Today, rock 84001 speaks to us across all those billions of years and millions of miles. It speaks of the possibility of life. If this discovery is confirmed, it will surely...
More recently, claims that the chemical phosphine, possibly associated with life, had been detected in the atmosphere of Venus. In the end, these claims and many others have not held up. There have been these big claims that make it sound like, wow, we found life beyond the Earth. So a big goal among the scientific community at this point is to figure out how to share the messaging correctly. We don't want people to think, oh, we found life, and then we have to pull it back. Still, scientists believe the stakes are so high that the quest is very much worth pursuing, and a telescope like the Habitable Worlds Observatory may be our best bet on settling some age-old questions. Did life only ever arise once in the universe here on Earth, and we're just so lucky and amazingly special? Or does this happen regularly through natural processes that unfold on lots of planets, and there's all kinds of life out there? To be sure, if we do find life beyond Earth, it's far more likely to be some kind of slimy, algae-like organism than anything we might have a conversation with. After all, algae and bacteria flourished on our planet for billions of years before the first mammals came along. Even so, such a discovery would cast our place in the universe in a new light. Thank you for watching the Cosmos News YouTube channel. If you enjoyed this video, please give it a thumbs up, share it with your friends, and don't forget to subscribe to our channel for more exciting content like this. Your support means the world to us, and remember, keep looking up at the stars. Until next time, stay curious and keep exploring. Thank you again.